Okay. Hi guys. Good afternoon. So to, I'll introduce you to Godot. We are starting introduction to game engine using Godot, and we started one last yesterday, and we talked about Godot engine, how we can use it to make game, what is the pros of Godot engine, what is the difference between Godot engine and other engine, what make Godot engine unique, and we also talk about how to make like a body, physics body in a 2D environment in Godot engine. Yesterday we ended at making a rigid body. Like if we are here yesterday, we ended at making a rigid body 2D. So let me just open it up. So we ended at making a rigid body 2D and we made something like this. Yeah. So we developed something like this. I want this session to be like interactive. So if you need have a question, because the thing we're going to do next is working on the kinematic body 2D, and in that kind of thing, we have to go into some coding. So if you have any question, you can ask, and I will try to find a way to explain it as I'm going. So without any further ado, let us begin. So today we are going to we are going to create a kinematic body 2D. In this environment, I'm going to teach you how to script it, how to attach a script to a node. And I'll explain how like all the major functions of a script, how they work, how they are triggered. And then we'll talk about kinematic body, how to add graffiti to a kinematic body, how to add movement, what is the logic between adding the movement to a kinematic body, and all of those things. I'll do all of those things. I'll talk about all of those things. And if you have more time, then I will send a GitHub link by the chat. I don't know how to send it. So you can download the nest. So you can download like I have like a GitHub that I have some assets and tile map, so we can use to learn the next lesson, which will be animation, how to animate your character. So let's begin. I hope everybody is ready. So to add the kinematic body, the same way we added all this rigid body, you click on this plus button or you press Ctrl A to take you to the create new node window. And yeah, the name of the node is kinematic body. There are two kinematic body here. There is kinematic body and there is kinematic body 2D. This one is used for 3D and this one is used for 2D only. So make sure you click on the 2D object, the one that always have 3D. If there are two, the one with the 2D is the one for the 2D object. So click on the 2D one, and yeah, you have a kinematic body. So this is a kinematic body, as you can see from the option, unlike the rigid body that has like all these properties, node, mode, mass, like everything has been coded, everything has been there. So you just have to change the parameters to get a physics body. Kinematic body will act like a rigid body in the first instance without the code, because as you can see, because if you give it a sprite, let us give it a sprite, let us add I'll give it a sprite. As I explained yesterday, a sprite is like the image of that body to showcase to the player that this is the body. Like we use a sprite to showcase to the player this is the this visual to showcase to the player that this is the body. Like this is our player. That is what sprite does. So we put this texture into the sprite. So yeah, can drag this out. So let us change the color of this so it's visible. We go to visibility and change modulation. Let's give it right. So and then, as we said before, we said a a body does not, it's not complete except it has a collision shape which will make it a matter. Like this is still like a ghost. It's just visible, but nothing can collide with it, and it can't collide with anything. But if we want it to collide with something and we are trying to interact with the environment, we need to add a collision shape. So this so this is a collision shape is added, and then we adjust the shape to the sprite, and yeah, that's is how that's how you add, like that is how you create a kinematic body. That is basically, that is everything. You've created the kinematic. Let us call this like a player, because we are going to, this is what we're going to do for the player. Like just let me just list what we're going to do. Let me open a word. They're going to do the code. What the code we are going to do is going to, like everything is going to do. Mhm. Sorry, I'm opening my word so I can showcase what. So the first thing we want to do that you can imagine body is make it like we add gravity. I will showcase the script to add gravity. We add gravity. As I said, this like this in Godot, it is like a graph. This is x-axis, this is the y-axis. But unlike a normal graph that we draw, the y-axis is inverted, so positive down, negative up. So we add gravity, so the gravity will just be, we'll just say we just add 10 to the y-axis, add 10 to the y-axis continuously. That is this thing. Like in normal life, a human being, like in normal life, everybody's getting a force of 9.8 added to them every time. As I'm sitting down here, I'm having gravity added to me. That's why I'm not floating. So we add gravity to the player every frame, every frame, like every frame in gaming. Pieces game word run per frame. Like the image on your screen, are getting redrawn every frame. So we want to add gravity to the player on every frame. So 9.6 times on the player every day, every frame. So on the y-axis, we'll be adding y, let's say y plus equals to 9.6, 9.8, let's say 9.8, okay. So we have a gravity of 9.8 added every time the player is, like every time, every frame. So that is one of the things we want to do. The next thing we want to do, we are going to we are going to add a friction. We are going to add not friction yet. Let us skip. Let us move down. So we want to make it so that once you click left or right, once you click left or right, we want our player to move left or right. So there are different ways to do this. There are different ways to do this. We can do it like, let's go left or right. Like I want to move our player, point to the left or right button. We can use a conditional statement. Yeah, I hope you have some knowledge about you programming. Conditional statements like if statement, if else statement, else statements. We use conditional statements like if left button is pressed, left button is pressed. I'm just using English here. Left button is pressed. Move, like you add the force to the left side. The force to the left side, our left, as we said in the graph, our left is minus. In x-axis is minus. So you will now be x minus equals to it. Let's say the speed. What's we had speed too. Our speed will make an variable for our speed, our movement speed, apply our movement speed. So if left is pressed, we add this force, we have this speed, we have this first our player, so it was going to be moving to the left. So we are going to have something like this. Can I draw? Can I draw? Can I draw? Yeah, having something like this. Yeah. Mm. So something like this, the force will be going like this, and it will be having to move the player to the left. So that is the plan of this. For the right, we add plus equals to, or you can use else. In unit, in I said like in normal in good in GD scripts, if you want to write an else if, it is called elif. So you use elif to check. So so you use elif to check if the right button is pressed, and then we use plus equals to speed. So just these are the things we are going to do. We are going to add graffiti to our player. We are going to code it. We are going to add graffiti. We are going to add our if our left button is pressed, if our right button is pressed, move to the right, and then we are going to add friction. We are going to add friction, because without friction, I'll show you with what happened without friction, and I'll show you what happened if there is friction. We add friction at the end to friction. As you explained, friction is how everything in our environment move and stop, because without friction, everything will just keep moving. In the frictionless environment, everything will just keep moving. So we need friction too. So let me showcase the code. It is simple. So this is how you add the script. You click on the node. You click on this script, this button, this script button, or you go down and click on script here on the property. Click on new script, and then you have something like this. It contains the language. Ask you which language you want. Native scripts, visual scripts. We don't want. We just want to use the script. It will tell you. It will ask you which node is it inheriting from. Since we are using kinematic body and we want it to inherit from kinematic body, we want it to inherit all functions from kinematic body. Like we are going to use all those functions here. So ask you the class name. We don't want to use a class name, so just leave it. So ask you the template. Like if you have some templates, yeah, but we don't need any templates currently. We can level it, but let me put it for default. They will ask you to use built-in scripts. Now we don't want to use that. Can ask you for the parts. So you can pick the part. You can add like a script. Yeah, let me not put in capital. A script folder here where you can add your player, and there, that is it. You have your player with a script. Now you can see the icon, the script icon. Your player has a script. This is script attached to your player. So now let's start. I will explain like GD scripts, like the major functions in GD scripts. In GD scripts, we have a lot of functions, and one of them is this ready function. Ready function is only called once the this node is instance. Like let me just say this. Let me print hola. Let me print ready. Just showcase this ready. So if you run this ready is just going to be called once. As you can see, this ready is just going to be called once, because and it's just called at the beginning of the process, because yeah, it's a ready function. Everything, that is how ready works. It is called at the beginning, and that's all. That is called at the beginning. It's not going to be called again, except you call it yourself again. So ready functions are only called at the beginning. So we also have process. We have process function, and it has a argument. It has an argument called delta. Delta is the time, like the time per frame. Delta frame is the time per frame. So 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 games run at a certain time, like it has a time that is run, and if you are making something that you don't want to be affected by lags, like if the game is lagging, and you want it to work based, even if there is lag, that nothing, not like, not, it's not look like it will cause a problem. If the system is slowing down, the game will also slow down with the system, so everything will process, everything of your game will not be lagging after if the game is like lagging. So you use delta time to your calculations. So your calculation will be perfect, even if the game system is slowing down, or if you are using a fast system, you get the same experience. Like if you are using a slow system, and if you are using a fast system, you get the same experience. If you don't add this delta to your calculation, you won't get the same experience. So physics process, a process function is called every call every frame. Let me showcase it. As you can see, it's getting called it's going to be getting called continuously until your point this thing is filled. Like if you want a code that is going to be running continuously in your code in your programming language, then you use a process, like a process function. Like everything that code will be running continuously. So that is the physics process. And we also have something called the physics process. That one, unlike the process, or the same thing as process, it runs continuously. But like process, it starts like a fixed frame, like number of frame before it runs. Like a fixed process will, it's not like fixed. It can do it anytime. But a fixed process will run at a fixed time along with number of frame, like it's going to run at fixed time. So we use physics process for mainly for physics based calculations, physics based function, like our kinematic body movement and stuff will be done in the physics process. If you do it in process, it will work. But if we have to make into consideration as game developer, you have to make into consideration that not all people that play your games are having high end system. So that is why you have to use physics process, because well, you want everybody to have the same experience with your game, and to have that, you have to make it so that at least even if the person is using potato system, they'll be able to play the game. Like yeah, they'll be able to have fun in the game, even if it's slower, they'll still be able to have fun. So the process is for other things that are not physics based. Other things that are not physics based. Physics process, like let me just type it out. Physics process are things that are physics based. For things that are physics based. And we have other things too. We have func inputs pass. This is triggered whenever you make any input event, like you click on your keyboard, you click on your mouse, you click on your pad. That is when this one is triggered whenever there is an event, like an input event. And yeah, we have a lot of input device like mouse, keyboard, scanner. All this thing. When there is an input event from all those input devices, that is when this guy is triggered. So let me just point input here, and let me show you how that works. Input, just say data. Yeah, let me just say mouse. I can't just be so. So as you can see my mouse here, if I click, yeah, let me just click in the node. As you can see, yeah, it's tell me that my mouse is clicked. It's because I clicked outside. The button was continuously registered. So let me just see. As you can see, as my mouse is moving, even the mouse movement is also calculated as input. So that's how input you can limit it. You can limit it. You can use if statement to get this event, to get which kind of event this is. So currently now we are back. I'm going to showcase how to set an input. We are back to track. Just explain. So I've explained all these guys. So let us just go back to what we want to do. So we first thing first, let us use a physics process. This process we pass. So first we are going to create a variable. If you are new to variable, if you are in programming, variable is where you store data. Where you store data. So in Godot, in GD script, you initiate a variable by using var. Like Python, where you just write the name, you have to write var, and then you put the name. Let us say motion, because we are creating a vector2 variables to store all our forces. Then we use a built-in function in in kinematic body to process those pieces. Like our work here is just to show how the force are applied, and then the kinematic body function will process them. So we have a vector2 function. Vector2 variable is used to save vector2 variables like our x and y axis. Currently, we are going to be saving 0, 0, like the force are not applying force at the beginning, so it's going to be 0, 0. So in this guy now, we are going to like add our gravity to it. So as we said in our writing, gravity plus equals to 9.8. So we can do that here, just motion dot y plus equals to 9.8. So yeah, we have to move that function, move and slide. Is a built-in kinematic body function that we use to save, like, to process all the force we applied. I use it to process our linear velocity. So we have it, we put motion.x, motion, we just put motion inside. So this will use to calculate like the force. Before, as you can see before, our kinematic body was just standing still. But after we do this and then we run it, it's going to fall. Like it has a gravity applied to it. As gravity applied to it. So that is how you have gravity, the kinematic body. It is actually very, very simple. Just apply the force in the process function, because this force is continuous. It's going to be every frame. The force will always exist, except you have some things like some game scene that you want a player to float. Then you can remove. You can remove that line, and yeah, but it always exists every time. Gravity exists every time. So that is why you are adding it in a physics process. So now to add like motion to left or right, we can just do motion dot x plus equals to 10, let's say 20, and you will see that 120 is going to be fast. So you see that it moves, yeah, very fast. It moves. It moves. So we are just going to use this function, this motion, this function to do our left and right button if our left and right button are pressed. So it's just a simple if statement. If, oh, before we said that, I want to like just show you something. Although we can use built-in button, but there is a way to assign button in Godot that is very, very simple, and I just feel like I should introduce that to you. So go to projects, go to project settings, and but in this tab, you will find your input map. Input map is where all input is. As you can see, UI accept, UI select, UI cancelled, UI. Like there are a lot of inputs here. So you can add your own input. You can say left. You can click on add. You type the name which is left. Any name you want. Click on add, and then it's added the input, and then you can add like a button to it. You can add physical button, which the keyboard. You can add a key. You can add a joystick like pad, something like this. You can add the joystick, you can add the axis, you can add the mouse button, anything. So currently using a physical button, then to ask you which button is it. So our left, you can make it arrow key, like arrow key left. You can also add our like normal game our A to it too. As you can see now, I have two buttons for my left. I can press left, normal left button. I can press A and see the left. So we do the same thing for our right too. Press D, press, yeah. So now we have our left and we have our right button assigned. So that is how you now in this function for our if statement or if input, you type input because this is from the input function. Dot is action. There is different function for its action. We have just pressed, we have just released, and we have pressed. Just press is triggered when you first click on the button. Just release is triggered when you when you release the button, when you first release the button, like it just called once. Just press just called once, just release just press one. And it's pressed is called continuously as you keep holding the button. So just press is used for like for like abilities. Just press is used for like abilities, or and just press is used for like ability that just needs to be triggered as the button is pressed. Like if you play, I don't know, some fighting games, so you just continue the combo. But yeah, which game is that? I yeah, but just press will only be triggered like once, but currently our movement button, we want it to be continuous. Like if we want the movement to be continuous, we want it as the button is pressed, we want it to keep applying that same force continuously, not to stop at all. So we are going to use this action pressed, like pressed. So as this, it will tell you which action you want to add, and then you see your left, right, UI accept, like all those that was saved at the this thing. So currently we are going to try left first. So left is by this, left is by this side, that is minus. So we are going to apply force of minus here. So motion.x equals to minus, let's say minus 100, minus 100. So we use an else this, or you can just use another if statement to check if input dot is action first, right. So once the left press our motion.x, we are going to change in the x axis only. Our motion.x is equals to 100. Once our x is changed, our motion.y is equals to 100. So if we do something like this, it's going to fall. It's going to fall. But then if you press A, as you can see it moving. If you press D, as you can see it moving. But as you can see, I'm not pressing anything, but it still keep moving because no friction. So to apply friction, except if it hits the wall, except if it hits the wall. So to apply friction, this is what we are going to do. To apply friction, friction is actually easy. The function of it is actually easy. We use lob motion.x equals to lob. This lob like it's, let's just go to the function. You can control click on a function to get what it does. So it's linear interpolation between one value, two values by the factor of the weight. to perform interpolation, weight should be between 0 to 1. However, value outside the range are allowed to use to perform extrapolation. So this we perform a linear interpolation of our force of our speed and our we use like something like this. We are going to be using our motion.x, which is our current speed, and 0, which should be the end, like the no speed. Like if there is no speed, our if there is no speed, 0. And this weight will now be our friction. Like if you want a smaller, you can use 0.1. If you want a smaller, like you want the player to slide, we can use 0.05. The player will be sliding. We can use it. Just let me just showcase the button and press it so we can see it visible. Yeah. So we can see, as you can see, it's sliding. Player is sliding. You can see the player is sliding. If we want like a grip, a tight friction, we can increase this to like 0.5, and then it will be very, very tight. As you can see it's very, very tight. Like in games like Splunky, no, it's not Splunky. Games like Celeste, their friction is very, very tight. They are using a tight gameplay, so everything is tight. Like the jump is tight, the movement is tight. Like if you press a button and release it, it's going to stop directly because they want you to calculate everything, and if you make any mistake, it is your fault, not on the game. Even the game even compensate for your mistake sometimes, but that is story for later. So yeah, that's how you make a kinematic body for a player that can move around, that can do stuff and stuff. So now I'm going to explain like something that we call export variables that you can use for your game. Like this value, it's just too much. If you have something like this, just visible, you like something like this. We want it to have. We want to save this in. Okay, just we want to save this in a variable and exchange this value with this, so we can change it directly. It's because currently, if we want to change this, we have to like change this to 90, then change the other one to 92, which is not cool. So we have to. So I'm going to explain export template. Export template is like how you can see this guy and you can see all these variables. Export variables. All these guys outside. Export variable can be used for something like that. We can have our graffiti outside. Export uh graffiti equals to 9.8. Let's save it. If you go to our player now, you should have a graffiti outside, like you can see that we can change 20 and to affect the code. Yeah, is 20 graffiti to affect the code. Oh no, it's not affecting the code yet. I have to change this graffiti to graffiti. It's not affecting the code yet. So yeah, as you can see. So we have export variables that we can use to just change something. Like if you have a big game and you just don't want to go into the script and changing the player variable and stuff, you can have export template, export variables that you can just change the editor and you won't have to go into game. If you have like artists in your team that are also using the same engine that also want to check something in the engine, you have to use something like this. And yeah, you have to you don't want them to touch your code, you just want them to work outside. To you use something like this and they're able to work outside. So another thing you can do, another thing, so we also want to export our movement speed, export file move speed. Let me make this 200. 200. So move speed. Now, can add something like this. So now you can change the movement speed outside the level. And let me just do this. Let me add this. Okay. Okay, here that is working. So I can change this guy here. Mm, I want the two of them to be by the shoulder. Yeah. So I can change this guy here. Currently, as you can see, our speed is like this. I can change this guy here to 500, and then I go back. Yeah, as you can see, it's moving faster. So it's moving faster. I can change this to 2000. As you can see, it's 2000. This is kind of slow. So yeah. So yeah, chaos is happening around. So that is how you 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 do like kinematic body, you do the movements. And so let us try doing jump. Let us try doing our jump. Okay, let me just change this back to 100. Back to 200. 200. So we want our character to jump now. To jump up, jump down. It's actually easy as you expect. We just have to, instead of adding to our motion.y, just subtract from it. Let's go up. Yeah, subtract from it. We just subtract. You also have to apply force that's greater than our gravity to jump up. And then after which a certain height, gravity overcome it, and then it will come down. It will not be a constant force. It will just be like in this point of the moment, like once the space is pressed. It's not be like if the space is once the space is just pressed. It's not be like if the space is pressed. If the space is pressed, it's just going to be going up, going up until you release space and then it come down. And there are games like that. Yeah, there are games like that. Something like that can be used for floppy bed, but we are not making flappy bed currently. We are making just a normal platform where you jump up and then you come down directly. So you are going to be using normal function. So that is just if compute. Let us. I really want to give an assignment, but should I? I don't know. Should have been great to give an assignment. But let me just do this. I think I have an idea for one assignment. So jump, added it's going to like jump. We are going to use a space bar. So key space bar and then we enter. So now we have a space bar for our jump, our button for our jump. So we can use if impute that is action just pressed jump. So we are using just press as I explained before, so that it will not just be going up as buttons pressed and then until buttons release that will not go down. So we don't want something like that. So motion dot y minus equals to minus equals to anyone we use equals to minus equals to that same thing. So 1000 um, equals to minus 1000. Let us not make everything. So our this we want to apply a force of 1000 minus 1000 to our y axis so our player can jump. So if we try it now and then we press it to see our player is jumping, but yeah, that force is so much that it has to go up a log before it come down. Let me change that to like 500. So yeah, you can see player is jumping and you can move around, you can move around, and move around, and move around. Yeah. So that is how you this how you makes player that can jump, that can move around, jump. That is the the easiest way to make it. It's very easy. And you have a character that can move. You have already make almost completely make a full game. That is one of the essential part of a game. You have to have player that can jump around. If you want to make a platformer game, you need a player that can jump. You've solved that part currently. So now I just want to, since I have a lot of time, like I still have 20 minutes, I want to show how to keep bind a pad to your game. Just a fun this thing. Then I will explain what we are going to do tomorrow. And yeah, going to do tomorrow. Do I have my pad on? Why? Shit, I don't have it on. Yeah, I don't have my pad. I don't have it connected. Connected that. Sorry, I don't have my pad connected, so I can't really showcase it now. Yeah, sorry. So yeah, let's make this a variable, export um jump height or jump speed, anyone jump height equals 500. And you can go back here and add our jump height to it. So yeah, you can add the jump height to it and run. So that is basically how you do, like, you make games and stuff. So for the next part, we are going to showcase animation. Let me just showcase what we are going to do. Okay, I have this. Okay, yeah. Next part, we are going to talk about the before that, before talking about the animation player, let's talk about something, the UI. Let me just showcase you the UI, and you can just have an example on that. So I'm going to talk about UI, the UI nodes and how they work. So I'm talking about how the guy in, let me just, all these screen guys, how they work. So let me just stop saying that. So control nodes, UI is used in control nodes. You can put them directly in your scene. You can put them directly in your scene like this. Control, control. Yeah, and put them directly in your scene. This is what is used to contain your UI. You can put it directly in your scene, but they are going to lose one essential power of them. They can't really adjust to your screen. So to avoid that, because they are getting, their parent is not a UI, like it's not a type of, not their type. So they do adjust, they don't get the screen size. So and the normal UI must be able to adjust to any screen size. Like to be able to adjust a good UI, at least a good UI should be able to adjust to any screen size, like to the game on any screen size. Like they should be in the same place regardless of the screen size. To do that, you have to add a canvas layer. Canvas layer. This layer is where you place your UI, your HUD, your 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 HUD and stuff on your game. This is where you this is where you place your canvas. If you place a control node in it now, it will act differently. Act differently if you put it on a full here. It is going to fill your screen. Like as you can see, this is your screen size. It's going to be there. It's going to fill your screen. If you place anything on it now, and then you expand the screen size and you reduce it, it's still going to stay in the same place, at least based on the surroundings. It's not going to mess up and everything will be. So your UI, you have a lot of things in your UI. You have containers. We have containers. These containers are we have HBoss container, we have VBoss container. It contains stuff in a vertical way, like everything that's adding to it is placed in a vertical manner. And that thing must be of control type. If we are not control type, they are not going to be placed in a vertical manner. Anything placed in it, let me just add the label. The label. Anything placed in it, let's give it a name. So as you can see, if I duplicate this, it's going to be in a vertical manner. That is how the container works. Everything placed in it is going to be in a vertical manner. As you can see, we have horizontal, we have horizontal, you have each boss container. Anything placed in these guys are going to be placed in horizontal manner. If I have like the tests, should I use the tests? Let me drag one test inside. As you can see, they are placed in horizontal manner in an each box. And we also have something called we have a lot of things like other of the container. We have voting, we have checkbox. There are a lot of things you can do. If you want checkbox stuff, you add the checkbox. If you want voting, if you want health, if you want like health bar, use a progress bar, use a progress bar, progress, texture progress. The only difference between this is one does not need the texture, it is drawn by itself. Like you guys can see, it's drawn by itself. You can add a minimum a value of 50 and it will show 50. Like this one is already pre-built. You don't need to add your own texture, get texture online and do. And the one needs texture. Like this guy need a texture. As you can see, it's empty currently. You have to add a texture into it to showcase the health. Like you might have different type of health. You might have all those health that go anti-clockwise because it has a lot of feel, a lot of options. You can add health that go anti-clockwise. You can have health that are like this is the player face, and then it could be reducing until you can have something like a clock. Anything that is possible with this texture progress. So and then you also have tabs and stuff. A lot of things. Like if you want to make a UI for your game, it is a complete entire course on its own. You have to, but I'm just going to introduce them one by I'm just introducing them. You have texture rec to texture rec. It's almost same thing as a sprite. It's used to save a texture as the name as almost same as sprite. Just add a texture. You can expand it to expand to the size, and that's how that one works. So yeah, that's all about control nodes. That's all about them. You use them for UI. You can even place UI on your game. Like if you want labels on this ball, you want a label on it. Like if you want it to be called rigid, and place a label on it. Okay, my hand is shaking. So yeah, you can place. You can give this one rigid two, two. You can centralize it, and then if you want the game, it will be following the player around. Even yeah, as you can see, it's following the player around. Mhm. You can use it as a debugging tool to check the force that is applied on your player. Like in this guy, we can check the force. We can add a label on it. Label. Add a label on it. You can see the label has been added. You can drag it up, place it on it, and then we can use this to print out variable or tests. Like it's as if once you type something here, it's test dot test. So you just have to over get the and just put dots that name, and then equals to return it to a string because it is a vector 2 labels only take string, and then you put your motion in it. So it should showcase which first added. As you can see, this is y as this is getting a first added with it, and then you move left, you move right as 100, 100, 100. As you can see, as gravity is as gravity is applied, everything is going back to, like you see that it's going back to zero. First is set back to zero until it reaches zero and stop. And if you jump, yeah. So another thing we want to do, we don't want our gravity to be applied even when it's on the floor. Like it's just going to be sticking up. The gravity is just going to sticking up. So we do something like this. Something like this. And then once it reaches the ground, it stops at 9.8. Like it's going to reach the ground. It's not going to be keep adding the same gravity on it. And yeah, stop at 9.8. So yeah, okay. So it's almost time for recap. So this as that's all you need to code. I will try to make this file available for people who need it. So that is all you need to code physics in Godot. It's not much in 2D. It's not much. You just have to write something, a small line, and you are done. So that write something, a small line, and then that is all for physics. This is your problem will now start when you have like alternative. If you want to add like grappling on wall, working on platform and stuff like that, then you start having more. You have to add more code. If you add gravity and stuff, you have to add more. But it's still the same this thing. Now we are going to now just a recap of all we did today. We talked about kinematic body. We talked about how the kinematic body works, what is needed to add the kinematic body, and we talk about the function. We talk about all the major functions in Godot. We have the ready function. We have the we have the physics process function. We have the process function, and we have the input function. We do not use the input function here. We can use the input function for all these guys, but we just put it in process. You can use it in physics. But we just process in process. So we have all those we have all those functions, and then I could talk about adding gravity. So yeah, we are adding fiction. So we added fiction using this LEP, and then that's how you add fiction to your code, your kinematic body using Godot. We add fiction directly, and then I explain labels, control node, how they works, how everything can be, how you can add different kind of containers, different type of stuff, and that's how add containers. So for tomorrow, we are I'm going to send this. I'll ask you, I'll lead this guy. I'll ask you to create a kinematic body. I don't know if anybody is there. I want you to create a kinematic body in this scene. Where is it? Where is it? In this level scene, make a player here that can around, that can walk and jump, walk and jump, walk and jump, walk and jump, walk and jump. You just have to make like a kinematic body that can jump. And then tomorrow we are going to talk about physics. How to add an animation to your player, something like this. How to add animation, something like this, where the player can run, can jump, can can play, can do idea animation, can get hit like Mario, like take damage, can even double jump. Like I'm going to talk about all those things tomorrow. So yeah, I want it to be on time. We are going to talk about all these guys tomorrow. And yeah, I hope you enjoyed this class. Nothing, you don't have to disturb yourself, just add like a line and then do for it. Even if you don't find it, like if you don't find it in this, I will send the link, like what is it? The GitHub link on the Discord server. So if anybody wants to download it, then you can download it and play around with it. It's just a simple scene. The background that move down like this, and with the player. That is all. Just a simple scene. That's adjustable, sure. Just a simple scene. Just a simple scene. So just place a player and yeah. So I hope you have fun. I hope this class was very, very interesting because I also have fun. I enjoyed my I enjoyed my time. Why is it lagging? So I enjoyed my time here. Thank you.